Good morning. Welcome to lecture 25 on thermodynamics of materials. Yesterday, we actually, okay, note these two things before I start. Your assignment next 3 is due May 23 and your first test, May 30, 1 week later, May 30, 2023, 12 to 1 in the seminar hall. Okay. Now, I give you this thing, sorry, I forgot. So, this must be yours. So, this is the assignment, huh? Okay. So, next assignment, this runs 2 pages, okay. Only thing I want to tell you, this problem 3 is withdrawn. Problem 3 is withdrawn. Okay. So remaining it goes to 6 with 5 problems. Okay, you'll solve. Try to solve. You may not be able to solve, but you try to solve. At least read the problem. Try to understand the problem at least this much. So it will be sitting here. So can you take care of this or just you or he whom I give? Oh, so they can take care and return me. Yeah. It's okay. It's okay. It's okay. Thank you. So now, yesterday, last class, I told you what? When I concluded the effect of pressure, last class, question. No, I cannot. That I particularly don't want.
No, so actually we have a problem.
Which problem?
So we might be organizing our exercise very well on that day.
Also after, okay, it will be 12 to 1, so what time it will farewell? Give farewell after 1.
No. But we have already booked our
12 to 1. Then earlier, okay, that will be good also. So 10 to 11. That will you have already booked. So take the test and then go ahead. 10 to 11. Or maybe even earlier. Okay. Or okay, in that case I can change. 31st is a Wednesday. Wednesday you can come anytime convenient because I don't have any class. But okay, that is when first period, no problem. 31st. That is Wednesday. That is affordable. Yeah, actually you are off. First period off, I know. Actually you shifted that class. So you can come if it helps you. Okay, but not fast. I don't want to get into the June. I don't want to cross May. Okay? June I have to take another. Okay? This is already overdue. So okay. So time actually May 30 will be decided. Date, you think about this. Date may change, huh? Date of the cluster's date may change. Means may change. I'm writing this. Yes, see this. I give you 2 options. Or Monday. In that case, what happens? This is what? Tuesday. Oh, Monday I have a class. Okay, Monday you can make it 29 then. Monday will be better. That's right. Monday is very good option. Monday. What time? I'm wasting time actually. Monday.
we can discuss.
Monday. I tell you. Monday. What time? 11 to 12. Oh, Monday actually I don't. I wanted to have it for some reason. Do you have any class? Monday, first period. Monday you have class. Because 11 to I tell you what reasons 11 to 12 I can take. But the problem is that it actually you come down. This teacher comes on time. So that's why I don't want to keep him stranded. Okay, that is the problem. Monday's problem. I have no problem. 31st. Okay, Wednesday. You decide the time. So you have 2 options. See, Monday, Tuesday. Monday to see Monday.
31st is a good date. They will discuss with you.
31st. That is good. Maybe on 31st. See. Maybe on May 31. Okay. This is known. Okay. 31 will be actually you have a Tuesday there. So you'll get another day for preparation. That you do. Okay. No problem. and any time. It is totally up to you. Anytime, morning to evening, I'm ready. I'm ready. Anytime. 6 o'clock. Yeah, 6 o'clock, 7 o'clock. I'm available. I'm available. Totally, 5 o'clock. I'm always available. Okay, so may I start now? May I start? So last class, you recall? Last class, what is the last class? Effect of pressure on enthalpy. Last class? Last class, effect of pressure on enthalpy. On enthalpy. What we got? Can you recall this? Basis. What is the basis? For a pure species, for any pure species or substance, solid, liquid or gas, solid, liquid or gas, happy or gas. What is the relation? You know very well. Del S by del P at del H by del P at constant temperature is V times 1 minus alpha T. And we got what? Last day I told you, for solids and liquids. Note, for solids and liquids, your knowledge is very important. Del H by del P at constant temperature, effect of pressure on enthalpy means temperature is not changing, is what? Small. Is small. Reason? What is the reason? V small. V is small. What is V? Smaller volume. 1 mole. These are called condensed phases together. Remember, solid, liquid are condensed state as different from gas. So these are called condensed phase. Remember this. It is popular term, condensed phases. So when I talk about condensed phase or refer to condensed phases, then you understand solid or liquid. Okay. It is small because molar volume is small. This I told you other day. This is molar volume. Then for what is this? For ideal gas. What is this? Tell me. You know very well how enthalpy changes with pressure at constant temperature means isothermal process. You know number of times that enthalpy is not change, is exactly no change, is 0. So for ideal gas it is 0. And for real, what is the reason? Reason is different. V is not small. Gas volume enormous, 22.4 liters. As different from it is, okay, or 18 cc for water say. So what reason? Different reason. Reason is here. It is this term. That is alpha, okay, 0. Since alpha is 1 by T. You know, this was discussed. Okay? So that is alpha T is 1. That is alpha T is 1. And for real gas also alpha T is not 1, exactly not 1, cannot be, but is close to 1, is close to 1. So makes small. So all are actually no effect, as if small to 0. Okay. Is one of the small effect. So alpha T is smaller. So is approximately equal. But this is the reason. Now this is a pure species. Now for a reaction which involves number of species, which involves a number of also alpha T. So you write this leads to DH, del H, del P at constant temperature is, you write, small. Come in. Is small. So you have total. Okay. For a reaction which involves a number of species, with a single species, how can there be a reaction? I don't know. Is it a reaction? Hydrogen plus oxygen. Okay, Eg, like Eg, metal solid plus oxygen gas goes to metal oxide solid You know, this is this reaction here. Delta H again, for example, delta H d delta H by dp at constant temperature is also small. Also for the same argument, for the same reason. Okay, for the same reason. Okay, why? Delta H is what after all? Delta H is made up of heat of reaction or any standard name. H of product minus H of reactant minus H of reactant. So these are individually independent of pressure or insensitive to pressure. So these also, this is zero again, because ideal gas is zero. So no change. So difference is also, delta H also obviously will not, okay, is also small effect. So this value will be like this is small, this is small. So for a reaction, delta H is relevant. Delta H, product minus reactant. Delta H, remember, delta H is what? Recall delta H is sigma H product minus sigma H reactant. Product of and reactant, that is here HMO2 minus HM plus HO2. See, you can very easily follow. This is not sensitive to pressure. This is neither. Difference is even less because difference. So it is actually recall over. This is actually I wanted to tell you. Remember this delta H is not function of, is not very strong function of temperature. Okay, the weak function of temperature we can avoid this. Now let us go ahead. Can I remove all these things? Okay. Good, very good. Start. Now today start fresh. What you start? Okay. Acha. Okay. Next, consider the following situation. We learn something. Following reaction scheme. Okay, you follow this. First of all, you consider problem is there. If a problem is there, it is very useful. Then we can go ahead with the problem. Okay, solve it. The problem is to find, take up this, to find the heat of formation of WC, the tungsten carbide. Okay, this is solid. Tungsten carbide is solid. Okay, solid. Okay, solid done at temperature T. Heat of formation means, remember, heat of formation is a kind of heat of reaction. The generic name is heat of reaction. Okay, don't worry, heat of formation. Or that is W solid plus carbon solid goes to formation reaction last day. 1 mole of the compound, never deviate. WC solid. Okay, to find, okay, delta H heat of formation, delta H WC at temperature T is what? Question. This is the constant, heat of formation, enthalpy of formation or heat of reaction. So a particular type of reaction is called formation reaction. This is 1 mole of the compound. So see this. Suppose the following set of reaction, suppose the following set of data is given to you. Following set of reaction data given. How? Given. And with the help of this, you will solve this problem. What are the problems given? You are given this. W solid plus O2 gas 1 by 1 is WO2 solid. This is given to you. Okay, what is the enthalpy change? Right? Enthalpy change delta H1. Okay, enthalpy delta H1. What type of reaction it is? You can guess also. This is a heat of reaction. You can call it a heat of reaction, but this is a formation reaction as well. Okay, so, but anyway, delta H1. What is the second? WO2 solid plus CO gas WC solid plus 3 by 2 O2 gas. Since second, this is also delta H2, and delta H3 is what? C solid plus half O2 gas is CO gas. Happy? So this is obviously delta H3. Now, right, these three are given. These three data given. These three data given. Who gave? Who gave? You have to carry out experiment. Suppose you have yourself found this data in the lab. Suppose someone else has found it, but suppose you have generated these three data. The okay, importance is this: to find this. Suppose you have carried out experiments, generated three data. These data you don't have to carry out experiment. From these three data you will generate. This is the message. This is the message. The fourth experiment I will not carry out, sir. So that means what? I will simply add these three. Simply add these three. If you add these three, actually see temperature. You can assign temperature here. See delta H is function of temperature. Pressure also, but pressure I am omitting because pressure. So you can add temperature, temperature, and also here delta H on T, delta H2 T, delta H3 T, and also add T here, T. Sometimes we write in the middle. I tell you here. I write here T means T applies to everyone. Short, but see. Now I will show you, since I will actually make some cancellation. That's why I have given this. Okay. If I write T here, it means okay. This is T. This is T. This is T. Same temperature. Reactant product. So if you add these three, you will see these add. 1, 2, 3. You add. What you will get? WC you see here. W solid you see here. And sorry, very sorry. Oh, I am so nonsense. WC T, sorry, very sorry. Actually, please see. WO2 solid temperature T, cancel out. Addition, you will know very well. Oxygen is what? 1.5 is 3 by 2. Left hand side and right hand side likewise 3 by 2. So what remains here? Such a CO gas on the right hand side and on the left hand side, you know the additions very easily. So what you will be left with? WS solid temperature T plus C solid temperature T is WC solid at temperature T. This is verily the heat of formation reaction at temperature T. Or in short, I am giving you. I will help you. So we don't write so many T's. What we write? In short, that is in short. Okay, in short. Good, very good. In short, WS plus carbon solid is WC solid, and just to mark this temperature here means it is at a given temperature and pressure. Pressure I have omitted, but pressure, for the sake of completion, you also mention pressure. But I have to try to understand what I said. This is this. Okay, this is what? This is what? Tell me. So what is this? For this delta is WC, which is the question. Delta is WC, the heat of formation, heat of reaction, and it is nothing but by addition of this. So write that this is actually delta H1T plus delta H2T plus delta H3T. Yeah, you may have a problem. So this part is over. Next is, quickly, let's move on. Okay. Next is, I tell you, deal with this next thing. Next is, similarly, I tell you, consider another example. This is more important to us. Consider another example. In this line is what? Suppose you see C solid giving C solid plus half O2 gas is CO gas. This is okay. Again, temperature T, you can mention this, okay? So, so T I'm writing here. Huh? What is this? What is this by the? What is this like? Is it in formation reaction? A formation of CO. CO. Correct. Formation. Heat of reaction and formation type. So delta H, how to write formation reaction? Remember, for formation, for this particular thing, formation, write CO at this, fast CO. Means that species. That species is being formed. Formation of that species is under consideration. So delta is CO first of all, and since temperature is T, okay, this is I'm writing is given, I have already written is given this. And another is plus O2 gas is CO2 gas. What is this? Obviously similarly, actually can I remove this? This is conflicting. This is delta is likewise CO2 2. So to suppose experimentally found, say, given means experimentally found. Who will give us? Someone has carried out the experiment for us, then we are getting. Or we have to do the experiment ourselves. You generate data. The creditable job. You generate the data. So this is say, okay, I tell you say minus 20,000. This is a minus 30,000, etc. So data, experimentally found, say. So two data, these two data experimentally found, given, and these are given, these two data experimentally found, say, okay, say, found, say I'm writing because I'm discussing. Now question is, and suppose you are asked to find, and suppose you are asked to find, suppose, and now suppose, and now, add a now, and now suppose you are asked to find, what you are asked to find? Interesting problem. Find CO2 gas plus carbon solid goes to 2CO gas. This is delta H is how much? Call it equation reaction 1 maybe. If you label, then it will be easy for you to label. Delta H 1, temperature T. His question is what? Can you answer? Not only this, another one is what? Another at the same time, CO gas oxidizing to carbon dioxide, CO2 gas. Good. This is second label as second, sir, and the same temperature that I have the data for the for the given ones. These two questions. Now you suppose you carried out these experiments, and these two will you carry out two more experiments? Now your answer will be what? No, sir. Wow, what is the reason? Sir, with the help of these two, I will answer. I'll get this. By combination, okay, certain combinations, okay, similar to this. Actually, by the way, here I forgot to tell you, okay, remember, write here, this important statement, right? Forgot, please write here. I forgot this one here, still it is showing, fortunately, why these two are, why this is one step, this is three step, same. One step, W plus C is WC, one step, is same as by these three steps. Why? Because enthalpy is a state property, sir. It does not know. Since this is true, true because true. This is okay. This is true because enthalpy is a state property. It's a state function. It's a state function. Anyhow, I tell you why. What is the this? What is the this? What is this? I just have drifted, okay? Digress. What is delta H WC? Please tell me. Recall. I should. This is something I wanted to complete first. What is the reason, sir? State function. Why you made this comment quickly? Delta H WC is what? After all, this is nothing but HWC. Break product minus reactant. Basic break split is enthalpy product minus enthalpy reactants is what? HW, the reactants, two reactants for this delta HWC. So these value how will it change? At a given temperature, the state is specified. T, and pressure also, since pressure is, right, the same pressure, same pressure. This temperature pressure enthalpy is fixed forever, whichever way you go. As long as you producing tungsten carbide at this temperature, say what temperature? It is say 1000 Kelvin. Say pressure is say 1 atm square. So this is forever has a definite enthalpy. Whichever way you actually consider, you prepare here, you prepare elsewhere, maybe abroad you prepare, in a different laboratory you prepare, or it actually comes in a reaction, but it has this enthalpy. So this enthalpy, so here also these are enthalpy. So you actually added means in cancelling out and retained. These are retained. Okay. So these are state properties. Enthalpy is a state property. So it will never change as long as this you actually meet. Right hand side you meet, this left hand side. So this is the enthalpy is a state property. Remember, whichever way, how many times you, whichever way you do this, this is correct. Okay. Now this is fixed. This is fixed. This is fixed. This is fixed. So difference is fixed. So delta is fixed. Okay. So same story here. So same story. Now what is the answer? No, we will not carry out. Now will you carry out separate experiment? Will you carry out separate experiments to find delta H1 T, delta H, oh, this is unnecessary, and delta H2T, this is the question. What is the answer? Answer, no sir, never, no, never. Will you carry out? Answer, no. So how to then get this? But you have to get this value now with the help of this, okay? Because what you know, how to get this? The results will be the answer obtained from the given data. The answer is obtained from the will be obtained from the given data. Quickly from the two given data. Now we follow one thing. I tell you, and then answer is what? I'm writing here, So I'm writing here now. Now I'm removing the question. Answer is I'm giving the answer here. Here I'm giving the answer. Follow this, then I will explain further. For the time you get the answer. Any reactions? Is it formation reaction? These are formation reaction. Is it formation reaction? It violates all kinds of criteria for formation reaction. You are saying yes. This how can it be 2 mole? So how can it be formation? First of all. Moreover, other violations, tell me, other violations. Yeah, constituent elements. Where is and why you are actually saying okay, sir? So no, these are not formation. But then what these are? Heat of reaction. When nothing works, heat of reaction, enthalpy of reaction. So delta H12 is what? Answer is, remember, I am correct. This can be expressed in terms of formation. This one is what? How many here? 2 moles first product. So delta HCO T, formation of this 2 twice minus come this side. What is the formation? Which is the formation here? Form stuff. Left hand side, how many? This is the form product, compound. This is no, this element. No, that does not apply. So answer is this. 2 delta H, I am very sorry, 1 perhaps. 1 delta H CO2 2. So this is known, known. What is this practice, sir? What is this practice? Is what I tell you. Can I remove this? Remove this part. Unnecessary. So we are expressing. Acha, I give the answer. I tell you. Then this will be what? This will be what? Come this side. This will be what? Start formation CO2. Delta H. Formation is a change, not H. H is absolute value. Formation H is absolute value. This is a change, absolute. Change, absolute. Absolute. Their difference is a change. Product enthalpy minus reactant enthalpy. So formation is what? Tell me this is, yeah, right, similarly, how many? 1. Delta H, formation of the product, and which are forming here? Which are CO alone. O2 again back is not. So delta H, CO, T, you remove all these things, and this is your answer. This is the answer. Okay, known, right? Known. Done. So why suddenly you do this? Suddenly you do this, sir. This is formation. Remember. So we are expressing here. We are expressing the heat of reaction. Heat of reaction. Heat of reaction for any reaction. For any heat of reaction, for any reaction in terms of yes, in terms of formations, formation reactions, in terms of formation reaction. Why, sir, formation reactions? Now this is very interesting. Why, sir, formation? Why interest? Interest is what? This, remember, formation reactions are measured experimentally. So use this value and get the answer for this ordinary reaction, any other reaction, general reaction. Use the formation values. They are tabulated. They are found. So formation reactions are measured and tabulated. Use this. But for this, you have used this is a technique. Don't consider C or O2 in this formation reaction. And moreover, this is a chain. You might now see, follow. But note here, note, I write here, note, however, note, follow this line is very important. However, what is delta H on 2? From the first principle, a basic principle, what is delta H on 2? Can you tell me? Follow. Suppose you don't know this, forget. I ask you delta H1, what is delta H1? Then what you should say? Forget about this part. This you are not aware of. But what is delta H1T? If you ask what is delta H1T? Well, H of products minus H of reactants. I am not saying many things. You say only a couple of things I am saying all the time. So it is not difficult at all. So what is then? Then tell me, what is this? Tell me. So let us see. You try. You actually see. Omoto will try. That is H of product. Always delta H is the change. Is H. H of product. A moment ago I have written here. H of HWC minus. So similarly, H of products. What is the product here? C and right. H of CO. But it is not. This is molar. This is 1 mole molar. So 2 moles, and you assign the temperature T. Just in the pressure also, but pressure I have dropped for simplicity. Okay. Then what? Then what? Product. H of product. C minus reactants altogether. H of good boy. And very good boy. Happy? Sir, this should be this. But why it is this? It is no matching. So this is 2HCO. This is delta HCO. Delta HCO is not HCO, sir. Delta HCO formation is what? Okay. Here you can break also. This also you can break. Delta HCO is you write the reaction first, then delta HCO is nothing but H of product minus H of reactant for that particular reaction, formation reaction. So they are, of course, they are not same. Neither is this. Neither is this. And there is C coming here. You cannot drop it at all for a basic definition. See the difference. But then are they different? No, sir. They are same. They are the same. That is the idea. Then which will interest us more? We will be interested in what? This or this? This. Yes, he says something. So Colin says this one. So, this is for concept, for knowledge, very good. But practically, we will never use this. Why? Who knows enthalpy at a temperature? Absolute value? We hardly know. Solid carbon enthalpy, who will know? Who will know the enthalpy of this stuff? Internal energy, who knows? I know. PV is internal energy, means you know all kinds of troubles. Absolute values, no one knows. In thermodynamics, you see first law, starting from the first law, and you see ever since we are studying it, changes. We are concerned with the changes, and helps. Change help. Change is measurable. Change is actually very interesting. But basic definition is very important. Fundamentally, this is fundamentally correct. And then you may argue, sir, can you show this is same? This is same, sir. This I will show you. This I will show you here. Acha. To show, this is so. So what is there any equation? Okay. So to show that No. So I will show that these two are same. Okay. No. Okay. Now I will show this expression. This is both are delta H1 2. These two expressions apparently look different, but actually the same. These two expressions, although look different, I'm removing these lines since you are already through. Look different, although look different, are actually identical. How? Sir, how? Because you said this. No, you have improved yourself. I'm trying myself. Okay. Can I remove this? I'm just taking one example. This example I have started. So if I prove here, you forever it will be proved. And not only this enthalpy, other thermodynamic properties are coming. They are also same. What are you doing? C plus O2. Okay. So very good. I'm just taking one case. I prove all cases, all reactions on earth. This principle. I am going to prove one. So can I remove this? Second one I am not taking because similarly you can. So this is my job to show this are identical. Demonstration. Okay. Yes, sir. Okay, right here. Identical. Demonstration. What is the demonstration? So that we will be convinced. Looks good, very good, because it is not conflicting with the original one, basic one. So, but this is very practical. This you will carry out experiment in your lab. There you will determine enthalpy change, formation enthalpy change. Okay, for reactions, heat of reactions in the for the. So demonstration start. I'm working here. Can I demonstrate here? See, start with better. I start with this here. Demonstration. Can I start it? Start will be better, na? Start will be better. Start face this side. That's all. Remove this, all over. Oh, by the way, before I rub it off. So what you found? I'm giving the demo. What you find? So two data given, two more data. You took help of them and found out. Means two experiments saved. You don't have the trouble of carrying out two different experiments. They are found from the previous result. Because what is the reason? How you put what you utilize here? Enthalpy is a state property, sir. See, it's same logic. Yeah, same logic. Enthalpy is a state. Anyhow you go. Okay. So this is same reason. Enthalpy state property. So this is actually kind of boon of thermodynamics. Okay, the state property is the great advantage of state property. It saves you. No one else saves you from doing experiment. See how difficult it is to carry out an experiment. 3 hours for data, thermodynamic data generations. Okay. Used to do, I don't know what. So we'll take up. But we will not do at all. This is the answer, smart answer, sir. Do your verify, you will get the same answer as you predict from the theoretical aspects. Okay. So please, so two experiments saved. That means two experiments you carry out, two experiments saved. This you have to note this. So that means don't have to carry out. So please show why sir this happens. So right. So here actually I have removed this, but let me. So demo. I start here. Delta H1T. I'm writing from this. 2 delta H quickly, and then we will be very happy once we are. Remove this, Then what is this formation? The formation I am writing for you, CO formation, right? C plus half O2. Tell me, CO formation. Don't violate the rule. What is CO formation? Formation reaction is what? C plus. For that reaction, this is the enthalpy change. And what is the formation for this? C plus formation reactions. That you see. So you apply that. You tell me here. 2 delta H CO. Forget 2. What is delta H CO? Somo, what is delta HCO? I've given everything. What is 2? I'm doing that. What is delta HCO? Yes, yes, Somnil, what is delta HCO? I'm giving help you. You can write whatever you can. You write whatever you can. H of C naught, first the right hand side. First the right hand side. H of products minus H of reactants, how many times? I am become hoarse saying this. H of product, a moment ago I said, yeah, H of products with a stoichiometric coefficient, H of reactants, that's it. For any reaction on earth, for any reaction, in terms of absolute value of enthalpy, this is the answer. In terms of formation reaction, this is the answer. But they are interchangeable. They are equal, identical. We are going to show that. So you take up only this problem. What is delta HCO? Here, suppose I ask you, what is the delta HCO? What you write? What you write here? Delta HCO formation. Last it is last days. Formation reaction you have written, and the enthalpy change after all. Formation is H of product, H of CO sir minus H of reactants together, half moles involved. Give temperature, okay? This give a temperature, assign temperature, and here also assign temperature. Because this is the, should I go back and then I could have written here, saving time. So since I'm writing that, I'm writing. You have got the job. What is the job? Starting from here, I will reach you there. That means then you will convince these two are same. This is fundamentally basic relation. This is a practical relation where you can utilize the experimental data given in the literature, in the book. So what is the two, right? 2 times that? Must be 2 times that? Tell me. Formation, what is delta? It is formation, right? That is product minus reactant. Now this time we are doing that. H. See, shall I break this? Shall I break? You don't mind, na? You do mind. 2 times I am breaking this. 2HCO minus 2HC. Take a look. I am avoiding HO2. Take a look. HO2. Happy? First term. 2HCO 2 times this. Okay, then you get these two results. Okay, temperature, you can write temperature, right temperature. This term, this over minus. What is this? What is this? Delta HCO2T. Now tell me, someone. Leopom, what is delta HCO2T? Good. HCO2. No one can contradict. Well, this is always true, sir. Enthalpy product minus H C plus H. I have removed this arrow this time. So space problem. However, note from the first principle. Write H of O2 temperature T. Now I am substituting this. In fact, I am substituting this one. If I substitute, what you will get? I am substituting here. See, who will say answer? Yes, Nijal, what I will get here? What is the right? Minus is given here. Tell me. What's the right? This. This I have substituted this. Then the minus is there. There is a minus. You know what is the influence of minus? It will make minus of this. What is this?
Minus HCO2 plus
HCO2, right. Plus both plus HC. Happy to? No one has objection? Baba? Where? Here, two times. It's okay. 2 times half 2 times means 1. Happy though. Now what you get out of this? Tell me what you get out of this quickly. Yes. See, plus HCO2 and minus 2 HCO2. Okay. HCO2 minus. I made a mistake saying anywhere. Now, what will 2 HCO2 is okay? Minus HCO2 plus, what is this? I started from here. Okay, very good, very good, very good. Very good, very good. What is the reaction under condition? Oh, how can it be so? CO2 plus is 2 CO. Don't worry, don't worry. Let it be so. Achha, this is cancelling. Cancelling. So, this is minus, na? Good boy. So I'm writing, see, follow last line. Check, it is coming back to HCOT, and this is what? Minus HCT. CO2 minus HC, then before this minus in bracket, HCO2T plus HCT. Are you not satisfied? So reconciled. Means, so okay. Over. So forever. Remember, both are same. Which one I use? Discretion, but what is the rule? So for actually use of the data never comes as age. Who will give age data? Tell me. Suppose for academic purpose I can give. This is the age of this. Then that's all. So you know this. Okay. What is this? This age. See, this is age. Follow. Age. What is delta H? Delta H. Formation graph. These data are tabulated, are obtained experimentally. Good. So this part is over. Next is remove this. Oh, sorry. Very sorry. May 19, 2020. Keep it. So next, remove this. Sorry. Remove all this. All over. This episode is over. Still another problem is this. Now, next. Now, delta H, heat of reaction, maybe heat of formation, heat of reactions are usually tabulated books. Tabulated where? Books or data book or literature. Tabulated at 298 Kelvin. For 298 Kelvin. For 298 Kelvin and 1 atmosphere pressure. Okay. Okay, happy? So how to find? How to find? Yes, I'll stop. Okay. And how to find heat of reaction means delta H. How to find delta H heat of reaction at any other temperature? Say 500 Kelvin. Happy though? This question I am answering. So what is the general topic? The topic is effect of temperature on enthalpy change. Effect of temperature on enthalpy change. On enthalpy change, let me write. T means temperature, effect of temperature on enthalpy change. For any kind of enthalpy change, delta H. This is given by famous equation, Kirchoff's equation. So this is your Kirchoff's equation, but you will do yourself. This is my suggestion, you do yourself. So you start with this, you follow this, effect of temperature. So I am giving the answer first. Answer is, this is the answer. The equation is, the relation is this. Suppose, follow with me. Delta H T2, temperature T2, you want to find what you know, T1. Generally speaking, T1 is the temperature you know. You want to find delta H T2. T1 you know, but see how many temperatures they will tabulate for 290, 299, 300, 400, 500, 600, 700, 800, 900. No, you don't have to. Again, problem. Thermodynamic. No. We'll find. Okay? And if your experimental results are vary, then your experiment go wrong. Not the theory. So this. So I know this, found experimental, I want to know this. Suppose this is 298, this is 500, okay. So maybe this is T1. So plus, say 298 Kelvin, say, as I have written there, 298 Kelvin, say, since I have written there, so you understand. I mean, same line, plus delta Cp, dt, T1 to T2. Delta Cp is what, sir? Delta Cp is the, again write this nicely, sigma Cp products minus sigma Cp reactions. I will show you how, with the help of the reaction. Happy? Quickly. It's happy to, this answer, box this. This is your famous Kirchoff's equation. But I am giving you more elaborately, quickly, proof here. No, we are not following Kirchoff. This is a result I am giving to encourage you with the final thing. Final thing is this. Delta Cp is difficult. Cp, heat capacity, we have taken how many days? Maybe 4 days. CPs, you know, heat capacities. How many times? So Cp data are available. Cp product means Cp of this plus Cp. Yeah? So Cps, you know. So Cp. So you use that integration, you know. And then this is also I have already giving one experiment done. Oh, you have to carry out one experiment. Then this experiment is paired, obtained from this relation. So quick proof, and then we'll stop. Lot of things, okay. Monday will complete. D note proof. We know. Start with we know. For a single species or pure substance, for a single species, we follow this. This is a very interesting approach. Quick proof for Kirchoff's equation. This is what? You know, today also we discussed del H del T at constant pressure is del H del T at constant pressure is Cp, dH is Cp dt. Constant pressure dH is Cp dt. So back and forth move. Brain actually should always be in constant, okay, activity. Fast. dH is Cp dt. So you said dH under constant pressure dH is Cp dt. Cp is what? Cp, by the way, I can repeat. Cp is what? Del Q del T fast line, fast efficient, fast line. Cp is del Q del T at constant pressure, and del Q is the dH. Del Q is dH very under constant pressure. Just replace. So forever. Happy? Okay. Now for one rule you follow. This. Can I write here a little bit? I'm writing this. Happy? Then if apply this logic. What is the logic? I'm showing you. If this is true, then I'm giving you write delta. I'm not writing here. That's why I'm actually doubling over it. Delta. Just this trick. Delta means delta refers to what? Delta. This is for what? Single species. Delta refers to chemical reaction. Number of species. For each species this. So delta H is that I'll show you. Delta H, you know, delta H. So delta and then delta. This delta Cp is the delta Cp. I'll show you. Okay, follow this. This leads to this. Now this I'll do. So but write this. Now for a reaction involving a number of species. E.g. metal solid plus oxygen goes to metal oxide quickly. I'm almost done. Don't worry. Metal oxide. So for each species, this is the rule. For each means for metal, for oxygen, for metal oxide. Okay. And what is then you subtract actually. Then what is the relation? It follows for a number. This for one species, for a number of species. Reaction involves, then it follows that what follows? Right final line. Follow this forever this trick you apply. Delta. So I'm writing that d delta H, d means delta, del H, del delta H under constant pressure is delta C. Very easily, delta HCP. Okay, this is this. For a reaction, this. For a single species, this. Reaction involving number of species, 1, 2, 3, for each species. How will you get this? Okay, see, quickly, quick proof. Delta H is what? You can do. I am giving you. What is delta H? Quickly, quick proof, quick proof, quickly. So delta H here. What is delta H? Tell me. H product minus reactant. I'm not writing anything. Minus HN plus HO2. Now you do this d dt. Follow d dt. Do d dt. So, del t. Here, then what will do? What will do here? Delta H is this. Delta T. What will do here? Delta T this side. If I do, then what side do? The same I have to do operation, sir. Operator both sides. Now equality is not honored. So delta T. Oh right, delta T given under constant pressure for you. So this is so easy that it is very difficult to emphasize. But I am doing this for, since you are not look very okay, pressure. Then here also tell me, again tell delta T, right? And right here, how will we get this? Then delta T, right here, constant pressure. What is the name of this? What is this? Delta T, ddt, what is the name of this? Anyone? DHMO2. But yes, yes. CP, sir, alone, single, water, sir. Where delta you get? What is the delta? See, you are correct in line. That's why I'm going to prove delta C finally. Don't jump into this. Don't violate the. Don't ever say to prove 2 plus 3 is 79. Because that helps you to get the answer. No. You rather argue back that no, why, sir? It is why right delta. I could have delta CP. Then next day when you. So this is, shall I write? This is, shall I write? I'm writing here, This is CP MO2. What I wrote. Hey, a moment ago I was asking, hey, this, that's the same. H of a species is MO2, sir. Can MO2 cannot be a species? So CP MO2. Then tell me here, CP M, good boy. You are in the line now. Plus CP. What is the name of this? This is delta CP of product minus CP product minus this is nothing but this is nothing but delta CP. So this is the quick proof. Okay, happy? So this I will elaborate on this further. Okay, further. Okay, thank you very much. With these words we have completed today's class. So let us call it a day.